Hello everybody, and thank you for joining me for question number 16 on the year 2001 grade 8 Gauss paper. That's the multiple choice contest aimed at the 8th grade level of mathematics. In the diagram, the value of x is, so we have options of 30, 40, 60, 50, and 45, and we're talking about this diagram over here. So notice we have x degrees up here. We're told 30 degrees down here. And these double dashed lines here, these hashed lines, indicate that we've got one isosceles triangle and one equilateral triangle. And for things like that, for an isosceles triangle, I know the angles opposite the identical side lengths are going to be identical angles. Same sort of thing in an equilateral triangle means that each of the interior angles on an equilateral triangle is 30 degrees. I do recommend that you, if you're going to keep doing math contests, that you know things like an equilateral triangle has all interior angles the same, and that they're all going to be 60 degrees. Same with a square, all the interior angles are going to be 90 degrees. A regular pentagon, they're all going to be 108 degrees. A regular hexagon, 120. There's a general formula for them. I think I'll write it out now that you should really know. We'll just write it down here just as it won't be part of the question 16 in our solution, but a regular n-gon, where n is the number of sides. Maybe we'll call it a regular n-sided polygon. Every interior angle the same. And that angle is, oh, I know there's a formula for it. I'm trying to remember what it is. I think it's n minus 2 times 180 all divided by n. Okay, so for, let's say, the regular pentagon, we'd have 5 minus 2, that's 3, times 180 degrees, that's going to be 540. We divide that by 5, and we get 108. By 5, 108. Okay, so every n-sided polygon has the same interior angle. I should say every interior angle here. And we have a formula for that. And this is a good formula to know because it can help you if somebody comes up to you with a question involving a regular heptagon. Okay? But back to the actual question at hand. So we have this little diagram here. So we have x degrees, we have 30 degrees. This length is that length, is that length, is that length. So this is an isosceles triangle, so I'll start filling some things in purple. So this is 60 degrees, this is 60 degrees, and this is 60 degrees. Okay. Now, if I knew the interior angles of this isosceles triangle, I'd be all set. Why? Because together we have a line here. So the sum of the angles in a line, a straight line, is 180 degrees. So if I knew this other interior angle here, that plus 60 plus x is 180 degrees, I can rearrange and solve for x, and x is what I'm looking for. So, in my isosceles triangle, I know that both of these are, we'll call it y degrees. So y degrees because they're isosceles, but some of the angles in a triangle is also 180 degrees. Straight line, and any triangle, all the angles add up to 180 degrees. So 180 degrees is 30 degrees plus 2 of the y degrees. We have 2 copies of y in there. So we subtract 30 from both sides. We get 150 is 2 y degrees, or y is going to be equal to 75. Okay. So we can add that in. So this is actually 75 degrees. 75 degrees. Okay. So that 180 is the same as the 60 plus the 75 plus the x degrees. (180 minus 60), which is 120 minus 75. So that's 50 minus 5 degrees, so that should be 45 degrees. So 45 degrees, that should be our final answer. And we'll check, is that one of the potential answers? It is, it's E. So our answer to 16 is E. And we can move right along to question number 17. We'll cover that in the next video.